Okay, Algebra 2, today we're going to be talking about quadratic functions and their transformations. So this is something that you would have seen in Algebra 1, but I recognize that math has been wonky for a while, including pandemic, including all sorts of factors, so I'm going to talk to you as if this is your first time seeing this. So with that said, these notes are very intense, and this is a difficult lesson. It's a lot of information, so I'm going to spend my time doing this well. So let's go ahead and talk about what things we need to look for, essentially. When you look at this shape right here, this blue curve, essentially, this is called a quadratic. This is a parabola, right? And this is the shape that arises whenever you have something that is like right down here where it says y equals x squared. When you square a number, this is the shape that comes around from our graph. It's kind of self-explanatory when looking at it. But I don't think I'm going to go into too much detail other than that. So what I'm going to talk about next is basically all the ways to label this. If you see this general form for the quadratic function right here, this is what contains all of our information. F of x equals a times x minus h squared plus k. Remember, these reference placeholders, right? A is a placeholder for a number, h is a placeholder for a number, k is a placeholder for a number. So those are there. Your vertex is h comma k. Your axis of symmetry is the line x equals h. What do we mean by axis of symmetry? Well, let me go ahead and take you to this one right here. This is the example we'll go to in a second. You see this? I have that as my parabola, and you can see it going on forever, essentially. What is the axis of symmetry? Check it out. You see that 3 on the screen right now? I am going to, basically, x equals 3. Boom. Right there. That is our axis of symmetry. So our axis of symmetry is x equals whatever the h is, the x value is, of our vertex. And the symmetry means it's symmetrical. It splits it in half. So symmetry, that's what that is. That's where that comes from. And it's really easy to kind of spot. I'll even show you the next one. So let's check out this one. You can see on this that we have a -4 for our vertex position h. And I'm going to go ahead and do that. Boom. Puts it in half. So that is what the line of symmetry is. So let's go ahead and start writing out information about this one right here. I'm going to get my pen going. And the vertex on this problem right here is at 0, 0. So I'm going to go ahead and write 0, 0. That seems like really thick pen. 1 second. Okay, I made it better. Okay. So that's our vertex, and it's that dot right there that is where the curve starts. Essentially, it's like where it meets. So that's our vertex. The axis of symmetry in this case would be x equals 0. X equals 0. And that's this 0 right here. You can see the axis of symmetry line is this thing right here. Make sure you have that down, and these are notes I would keep. Domain. This is going to be one of those fun things. Domain, I'm going to use interval notation. Domain in this case is x values. What are the potential x values that can go into this? And if you look at this, if you look at the left-hand side, you can see this left-hand thing going all the way over. But if you were to watch it, it would go left that way forever. And if you see this right-hand arrow, it would also go right forever, which means this is all reals. Our domain is all reals for quadratics. And it's going to be all reals more or less every single time. And you can write that using the old interval notation. Remember this thing from -infinity to +infinity? Jog your memories. We did it at the beginning of the year. I love interval notation. It's the way I prefer it. So that's how you write this here. Range. So let me do this. X is domain. Range is y. Check this out. Range is, what are the y values? So looking up and down, I see that my range is starting at 0, and it includes 0. So remember that thing right there. And then looking at my y values only, going straight up, this thing is going all the way up to +infinity. And if you've forgotten domain and range, don't panic. I'm going to help you out with that when you're doing your assignment. It'll click again. So now let's go down, and that's that. That's how you label this problem. That's how you get there. Yeah, there's not much more to say about this. So this is what the answers look like. Again, I would encourage you to go slow and try to solve problems one at a time. Don't do this quickly. So now, I'm going to go ahead and fill out these examples for you right now. Check it out. You see this thing up here? This is our reference point. This is what we're using for our reference point. So I'm going to go ahead and look at my problems right here. I see a 3 right here. Does the negative match? It does, which means my vertex is 3, comma, and then K, is there a positive here? There is, means 7. So this is one of those weird things that some of y'all remember. Remember, whenever we have the number next to the X inside the parentheses, we're going to take the opposite sign. So even though this says -3, we're going to take +3. When it's outside of the parentheses, we're going to use the sign. So this always lies. This X, this always lies, and this one is going to tell the truth on the outside. So that is our vertex, and once we have our vertex, we can get our axis of symmetry, which is X equals 3. My A is 5, my H is 3, my K is 7. So let's go ahead and do the rest. Let's get my vertex. Check it out. This sign is not negative, so that means we've got to switch it. It's got to be switched. But since this one always follows the truth, we're going to do this one. I have a teacher that taught me this little trick. She's like, you see these X's? Some of you with your girlfriends and boyfriends, you break up with your boyfriend and girlfriend because your ex is lying. So think of that little trick. Why did you break up with your boyfriend or girlfriend? Because he's my ex, she's my ex, and it's because she's a liar. So these X's, just like your ex, are liars. Anything next to you, they're going to lie to you. So remember that. X's lie. And so that's the end of it. Our axis of symmetry, once again, once you have the correct number for your vertex, you can just slap that down. You'll notice it's asking for A. There's nothing there. If there's nothing there, assume it's a 1. It's not a 0, it's a 1. So make sure you have that down. H is, of course, -4, and my K is a +9. So going to this, I'm going to show you what this second one looks like real quick. So it's the one I graphed already. You see this? I put my equation in right here, and then this is what we have. Boom. And then what's my symmetry? Boom. So that's how you check it. That's what it looks like. This one's interesting right here because it doesn't have everything you'd want in there, and it's going to be confusing, but watch what you can do. You can rewrite this just like this. When you have that 2 there and there's nothing going on with your X's, you can write your X right here. And even though there's no number there, right, those are the same things. It looks wonky. Obviously, the first one looks prettier. This one looks better, or it looks wonkier. So I'm going to show you right now what that looks like. So right here, where am I at? We're on the next one. Check it out. That's what this one looks like. That's the green. We have that there, but look what I edited it into. I can also do this, and this is going to be a color. You see that? Purple, green. They're the same thing. So when you're seeing it written in this form, remember that it's going to basically look like this. So there's missing information. So in this case, I have my vertex as, let's look. Let's make sure I got this right before just telling you crazy stuff. My vertex is going to be 0, and hopefully you can see why it's 0. There's nothing there. And then my -3 is going to be the K part of it. My axis of symmetry is X equals 0. My A is 2. My H, of course, is 0, and my K is -3. This one right here, I'm going to rewrite this one for you, so you know that you can rewrite it in the current form. F of X equals -1 times X minus 7 squared plus 0. There's nothing there, so you can write it that way. So this one up here is the same as this one down here, and I'm going to show you it now, because this one's important. So far, we've seen them going up and down, but check this out. Boom. You see that negative right there? That negative makes this whole thing flip upside down. And you can see, let me get that one. They're the same. They're the same. So even though that +0 seems silly, it's just there to help you understand the information and knowing how it works. So let's go ahead and fill this out. Our vertex is, let's do this. Is that a negative? Yep. So that's going to be a positive because our X's always lie. X's lie, y'all. There's a 0 hanging out over there. And then I have my X equals 7 for my axis of symmetry. My A is that -1 in the front. And what do you notice when A is negative? What do we notice? What do we see in there? Remember, when it's negative, it goes upside down. So my H is 7 and my K is 0. So that's the first holistic lesson. I am going to solve the next examples on the next video. So that's a lot, y'all. Kind of boring, kind of dry, but hopefully you can use this to remember how to basically label all these things.